Hi there, it's Mr. Allred. I'm here to talk about differential equations. More specifically, we're going to talk about first order linear differential equations. So let me show you what they look like, and then I'll explain the name. So the form of a differential equation, or at least a linear first order differential equation, will be dy dx, which could be written as y prime, but it's the first derivative. And then we're going to add to it some function of x, usually called p of x, times y, which is basically y of x. And then that will be equal to some function of x. So let's take a moment and kind of break this down. Another way this could be written would be y prime of x, which basically means it's the derivative of some function that contains x's. Okay, and then we have some other function that is only an x times y of x. So here we see a little connection. We see a function y and its derivative. So that's what we have up here. So there's the differential equation part. So the first order idea up here, when we say first order, we're talking about it only has a first derivative. Okay. So first order means only a first derivative. So that means you would not see a y double prime in the method we're getting ready to use, or a y triple prime. Okay, you can see a y and a y prime. Okay. Continuing this other side here is something completely in x. So a few things we need to make sure of here is what we see is there's nothing in front of the first derivative. So we'll assume there's a 1 here. So for the method we're going to use to solve these, there can't be anything in front of the derivative when we start. So keep in mind, if we go back to the idea of differential equations, what we have here as far as y is considered is a function. Okay, so this is just holding the place value of some function. And if we knew what that function was, we could put it in there. But the derivative of that function would be over here, the y prime or dy dx. So there's a link between the y and the y prime. And we don't know what those are to start with. Now, what we see here is the p of x and the q of x. There doesn't need to be any link between those two. Okay? They're just functions of x. So they're going to have a single variable in them. So the linear part here is it's a linear combination. It's a linear combination, which means it's added a function and its derivative. Okay. So if you're going to use the method I'm going to show you in a moment, you're going to have to be able to have y and y prime. You're going to have to be able to get the y prime by itself, and you're going to have to be able to get basically the y so that it's a multiple of something. And notice over here on the right hand side, there's no y. Okay, so the method we're going to use here is we're going to come up with what's called an integrating factor. Okay, and this is always, at least for the first order linear equations, is always going to be found the same way. This is basically e raised to the integral of p of x dx. Okay, so that's the first, well, possibly the second thing we're going to do. We're going to have to get our equation in the correct form. Okay, so there's a 1 in front, we have everything together, and then we can come up with an integrating factor. Sometimes it might be ready to integrate right off the bat. So it's not much use in going any further until we have something to work with. So let me pull an example from the book. So I'm going to do hopefully something not too difficult. Let's try this one here. So this problem is going to be 1 plus x times y prime, and that'll be plus y equal to square root of x. So this is an example. So first of all, let's see if it fits the form definition that I gave you of a linear first order template, or if we need to mess with it. So the first thing I said is you can't have anything in front of the y prime. So we can manipulate this. We can divide out what's in front there. So let's be careful here. So if we divide both sides or everything by 1 plus x, it'll cancel it out in that first term, but it will be a divisor in the y term there, and over here it will be a divisor on the other side. Now your y prime may be by itself to start with, but what's important now is that there's nothing in front of it. So if there's nothing in front of it to start with and it fits the template, you're good. Okay. If not, you're going to have to figure that out. Okay. But what we've got here when it's in the correct form, this right here is the p of x. Okay. And sometimes it may be a little confusing because if this is a subtraction in front here, you might forget it, but it's very important that you hang on to it. Now, not so important right now on the other side is this guy right here. You can see that it fits the form. It's q of x. It's a function only in terms of x. And p is a function only in terms of x. Okay. So, we're going to go for that integrating factor. We'll shorten that up, integrating factor, and that will be e raised to the integral of p of x, which is 1 over 1 plus x, and we'll integrate that in terms of x. So you're not integrating the e part here, you're integrating the exponent. You're integrating 1 over 1 plus x. Now, you could have all types of things up here depending on what ends up in front of your y that you call p of x. So every problem could be a little bit different that you see. But the e stays down here for now. And if you take a look at this, you can do a u substitution and it becomes the natural log of, it's a nice time to have colors. We'll call it x plus 1 instead of 1 plus x. So we got e raised to the natural log of something. Now in general, e and natural log cancel out, and we're going to do that. So this integrating factor will look like, when the e raised to the natural log cancels out, just x plus 1. So don't necessarily count on that happening. Okay. That the e is going to cancel out, but it is a possibility. It's pretty nice if it does. But that's our integrating factor. So I haven't told you what to do with that. So let's see. Let's take the last form of the equation that we had that was acceptable, which was this guy right here. And what we're going to do is we're going to multiply both sides by the integrating factor. So we're going to take this and we're going to say on this side we had y prime. Ooh, sorry about that. We had y prime. We will multiply it by the integrating factor, which is x plus 1. We've got plus 1 over 1 plus x, and I'm going to leave a little bit of room here and just go ahead and multiply it by the x plus 1. And then we have the y. Then on the other side we have the thing that was there. And we'll multiply by the integrating factor. Some examples, when you pull them, magic happens. But let's take a look at what we have here. We now have a new version of our original differential equation. Just kind of going back and walking through. Up here is where we started. We had to get it into the form, so we divided both sides by whatever was in front of the y prime. So we didn't change the equation, we just changed the way it looked. So we divided both sides by the same thing, so it's still equal. Now we divided both sides by the same thing, so it's still equal. It's still the same equation. Here's a few things that happen in this one. This is on top, this is on bottom, it cancels. This is on top, this is on bottom, it cancels. That will not always be the case. But let's see what we're left with here. We're left with x plus 1 times y prime plus 1 times y, and over here we'll say this is the square root of x, which is x to the 1/2. Now what we're going to do is we're going to integrate both sides. We're going to integrate both sides. Over here, this is definitely going to be in terms of dx. I'm not going to say anything about, well, it is in terms of dx, technically, because y is a function of x. But I want you to look at something real quick. Okay? This guy and this guy and this guy and this guy. This is a product plus a product. I want you to notice something here. If we take a look at this, u prime, okay, v prime, v. The derivative of x plus 1 is 1. The derivative of y is y prime. This is what the linear first order integrating factor does for you if you do it correctly. This is integrating a product rule. Okay, let's make sure we got a good color here. We'll go ahead to black, I guess. Integrating product rule. So my videos can't be more than 15 minutes long, so let's see here if we can make it happen really quick and then pick up a little bit later. So if we understand that the derivative of u times v is u times v prime plus v times u prime, we know that we can undo that. So if we come over here, we're going to integrate this right side as a whole. So it will be basically u times v. So we don't try to integrate these separately, these two combinations. On the other side, it's just in terms of x, so we can just use the reverse power rule. And if we want to, we can get this by itself. We've got x plus 1, we can kind of move over, divide both sides by it, and we'll have c over x plus 1. And now we have a solution to that equation up above. We'll stop this and pick back up in a moment. That example is done. Thank you.